Hi there, our studio friends, and it's Jordy here. Yes, I'm back again talking about research, our studio, coding in general, and I thought we could do something a little bit different today. You may be aware that I tutor people, I tutor students, and these students are generally in science, but they can also be like in economics or various branches of sciences like social science, natural science, psychology, and and these students are also bachelor's, master's, PhD, etc. One thing that comes up a lot, right, when I'm tutoring is research questions or hypotheses. How do we go about asking questions, coming up with questions in the first place? So I thought I could talk a little bit about that. And there is a little bit of stuff I want to show you in R, but not much. Most of it is just theoretical ideas and suggestions from papers. So, in terms of a research project, imagine you are given all the flexibility in the world to come up with a research question or a subject to study. This actually isn't totally uncommon, okay? And you might be surprised because some of the students actually have, they're given data sets with loads of columns in, and they're asked to come up with a subject, a project from that, a question that they can answer from that data frame. To go through the process of data analysis, okay? Maybe there's data cleaning involved. Data cleaning, data analysis, making graphs, making models, carrying out the right statistical analysis to answer their question. So that's another aspect of it that I want to talk about in a second. But in terms of coming up with a question in the first place, this could be a question that you're particularly interested in. Okay, let's view a data frame to give an example of this. Okay, so we're going to use the faraway library, and that's the same one that has the Gala data frame, which is the tortoises in the Galapagos, and I love that data frame. This one is called mammal sleep. Okay, view mammal sleep. Okay then. And yeah, this is a data frame that's in this library that contains information or lots of columns about animals, different types of animals. I'm not sure if these are averages or for a single individual. Let's see if we can, I'll make this a bit smaller. We're going to scroll through and look at all the columns here. There's information about how much the animal sleeps. Okay, this must be some time component here. And again, if you want to know more about any data frame that we talk about, you can go online and just Google it. Library faraway mammal sleep data frame. There's another column which is called non-dream. Okay, so that also seems to be a time component about how much they're not dreaming. Then there's all this other information about the physiology of the animals and about the environmental exposure, danger, predation risk. Maybe predation might actually be its predation risk, or alternatively, it could be a measurement. This is a sort of code here in this column. It could be a code of how much of predator it actually is. There's physiological measurements such as the brain size and the body size. No units are given here as they weren't in previous data frames, so again, that's something you'd want to check. But you might look at that and you might say, hey, you know what? I'm interested in the effect of body size on number of hours of sleep, okay? Or the whatever units this is. And so that is when you already see data and you have a question, you can come up with something that you're interested in. If you're not entirely sure, even after looking at a data frame, what you can do is you can use exploratory graphs in order to get some information about potential relationships that might exist between columns. Okay, let's load the core plot library. This is probably my go-to for numerical data, of which all of these are. The mammal sleep data frame is entirely numeric columns. They're either int or num, okay, the two different number types. And with the core plot loaded, we can plot all the columns against each other, and that might help us to come up with questions. So what you can do first is you can just write core plot COR, and then in the orange brackets, again, the colors of the brackets you have here will depend on the color scheme that you're using in the settings and the tools global options. Okay, and then we're just going to write mammal sleep. There are NAs in this data frame, so we'll see if this works. If it doesn't, we'll make another data frame to remove the NAs. Okay, right, so this is a problem now because there's missing data. It showed a question mark for any column that there is a missing data row in. So what we want to do is we want to make a copy of the mammal sleep. Let's call it mammal sleep 2. And we can base that on mammal sleep. What you can do now is, so that's a little bit like in tidyverse and when you're generally copying data frames, but you want to put prior to the data frame name, the original data frame name, na.omit. And then you can put the original data frame name in brackets. Okay. Now we're just to keep this kind of organized, let's view the mammal sleep 2. So we have that showing up in the source. And we can compare that with the other one. In the mammal sleep, there were 62 rows. In the new one with NA, if there was an NA, like for example, here, there were, in the mammal sleep, we had a bunch of NAs here for roe deer. Then if there's any, then the roe deer unfortunately would be removed. If you want to go further and just remove the NAs from certain columns, you can do that too, but we're not going to worry too much at the moment. We just want to show an example of how core plot can be used to come up with a research question. So then we can copy and paste the codes that we made before that gave us a dodgy looking question mark graph. And we're just going to put mammal sleep 2 here instead. Okay, so now we have a graph that actually works, and I talked about core plot and this kind of graph previously for empty cars. That's another strictly numerical data frame. The idea is that you ignore the blue circles diagonally down the middle, because each of those is plotting a column against itself. There's no point plotting body versus body or brain versus brain. Those are going to be indicated to you through this diagonal blue, dark blue circles. What we're interested in is everything else. Okay, so these are all the pairs, right? Pairs of columns being compared. And when you have red circle, that's a negative relationship between those two columns, as you have here, for example, right? Like sleep versus exposure is a pretty dark red, so that's strongly negative relationship. When you have a dark blue, with the exception of the ones down here, okay, it's a positive, highly positive relationship. So brain body size is being compared here, and you would expect those to kind of like scale positively with each other. As the brain size goes up in these animals, the body size goes up, vice versa. So looking at a graph like this can help you come up with a question too. In addition, you might be given questions by your supervisors or by your line managers or whatever, that those are the questions to follow. And by doing background reading, you might identify a research gap as well. I don't have it on me right now, but I saw. Okay, let's just see if I can find it on the internet. Coming up with a research gap. I saw a couple of nice images here on Google before. That's you can look through this. You know, it shows the there's lots of stuff here about like kind of gaps, whether that's a gap in technology, that is like you discovered a new technology to do a job, better technology, you've discovered a new method to do a job, you want to actually fill in a research gap that you've read in a paper. Lots of good stuff here. There's 7 types of research gaps: knowledge gap, empirical gap, evidence gap, methodological gap, theoretical gap, practical gap, or population gap. So feel free in your own time to look into different types of gaps that might exist in research. When it comes down to introductions of scientific papers, okay, I get asked a lot. In the introduction, should you make a hypothesis or just an aim/research question? And you can do both. The idea in some of my previous papers, this is just one as an example, I'm showing you papers that I've worked on in the past. This is on arrowworms, which is like gelatinous zooplankton. I haven't really had null hypothesis and alternative hypothesis so much in my publications. It's mostly been we describe the life histories, or we describe something. You know, we're making a description of something in the environment. Let's have a look at another one. Okay, this is probably my pride and joy paper. This was about arrowworms feeding non-carnivorously, and I do want to come back to the subject in the future, but I'm not doing it at the moment. The idea was that they're strict carnivores. I don't think so, especially for some species. So let's see, let's go down to the introduction here. In this study, we analyse the feeding history of the Arctic eating nymphs, E. hamata, Shikronia hamata, and Parasita elegans. Okay. We determine again the kind of describing, right? Determining the extent to which animal and non-animal matter are consumed. So these are kind of like, you know, allowing these kind of ways of framing aims and research questions allow you to have some flexibility in the results that you show and the stats that you run and the models that you run. There's lots of ways to go about a question like that, even in terms of the data that you collect in the first place. An alternative is like kind of strict null hypothesis, alternative hypothesis thing. And there might be a value in doing that for maybe a controlled experiment. Let's go down, these are all on Science Direct, so feel free to see if you can get them for free. If not, you can log in through the institution that you're with, if you are with an institution. There's other ways to get papers online as well. Let's look at this one. I won't read too much into the paper, but here, like we hypothesize, you're going to see the word hypothesize here, hypothesis. And here it's that you got a few of them. Temperature variation will have a more pronounced impact than salinity changes. Notice the direction of things here, huh? They're really specifying that one is higher than the other, and they're going to use graphs and stats to check that. High temperature exposure leads to higher routine metabolic rate. So this is really getting into the directions again. That would be a way that you could approach the body size, brain size relationship that we saw in the mammal sleep core plot. You could say we hypothesize that higher body size leads to higher brain size. Note that you might be kind of limited then in how to tackle the project, and you're really going to have to be sure about what you're hypothesizing in the first place. Null hypothesis differs from alternative hypothesis. because the null, this isn't written here, okay? Sometimes you might see the null hypothesis and the alternative hypothesis. The null is when you're saying there's no effect of brain size on body size, or body size on brain size, and the alternative is when you're saying that there is an effect. How you would check whether there's an effect or not goes back to p-values, and p-values are the chance, or the likelihood of making an error, okay, or introducing an error in your conclusion, okay, and therefore related to certainty in your result. The actual definition is like if all the assumptions of the model are met, okay, so that means that you need to make sure that before you interpret the p-value, you do have, in the case of parametric tests, normality, equal variances, etc. So it might be worth talking with a supervisor or colleagues about whether to use the style presented in these papers, more descriptive, or the more controlled hypothesis style that you see in experimental papers. And I didn't want to talk about too much more, but one thing I did want to say is that there's a library that can be useful as well, which is called bibliometrix. And I introduced that a little bit in a previous session. Oh, not bibliometrix, bibliometrix. Okay, it's related to bibliometric analysis. Then we can use this to get some useful information about papers from a repository. And that repository could be, okay, I'm just waiting for this to load, and sometimes it does take a while. That repository could be something like Web of Science, Web of Knowledge. And we'll see what the options are in a second when this turns up. If you got it from another one, which is the PubMed, okay, PubMed. I like PubMed because we do have a lot of papers on here that you can get entirely for free. It's more related to medical fields, so there might not be too many ecological papers on here if that's what you're working in, and that's what I've been working in the past. But it's like for anybody, even if you're not logged in, right? I'm not even logged in right now. Maybe I do need to log in. Let's see. But you can just get so many papers this way, and this is really, at least it was not known about in my field. Do I have to log in? Okay, anyway, we can view it. And this is my animal, by the way. This is the animal I was working on before, a ketognath, aka arrowworm. When you do log in, okay, you can create a bibtex or a text document with citations relating to a specific subject, and then you can import that into bibliometrix. All right, we're up now. Okay, so what we're going to do now is we're going to go to import or load. So again, this is a shiny app that came up in the browser. If we click import raw file, yeah, we see all the different databases that file can come from. It matters because the style of the document that contains all the references and citations will differ a little bit depending on where it's coming from. Scopus, Dimensions, Web of Science, PubMed. For now, I'm not going to bring any references in, and we are going to use, this bibliometrix to summarize the references from that document. I'll use a document in a sample collection, okay? The use of bibliometric approaches in business and management disciplines. So you just click start, and this is a good way to play around with bibliometrics without needing to get the stuff from PubMed or a database yourself. First thing that comes up, guys, is a kind of general table about the references that have been brought in that document. relating to this particular field. Again, I'm not looking into what the search queries were in the data frame, in the database, but it might be using some of these keywords, bibliometric approaches, business management disciplines. All right, just close that for now, okay? And let's move me over here. You get this, you see that now stuff has been brought in, and this table is showing the same table that we just saw. We're going to go down to overview here. Main information. First step is to get main information about the papers, the 800 or whatever that were brought in. Okay, 898 documents, that's a lot relating to this subject. Time frame 1985 to 2020. Plot comes up here showing a nice visual representation of that information. And there's a lot of information that you can get in the other sections, such as how many papers have been produced that are in that file per year, who the authors are, where they're coming from. One useful thing for data exploration can be something like this down here in clustering. Okay, let's go to here where we're going to go to conceptual structure, and we want to go to thematic map for now. Thematic map, and we're just going to push this button here. This bit here allows you to change some settings in the figure that's about to come up, but let's just wait and see what happens. Again, it's 868 papers, so it might take a while. This is the one. This is what I wanted to show you, okay? So these are some keywords from the papers in the reference list, okay? This shows that it's looking in the keywords of the papers. You can change this to be the titles or the abstracts, and these are the important words that are coming up, okay? But it separates the words into different themes, okay, based on how much people have worked on this. A combination of relevance and development. So you've got niche subjects, you've got motor subjects, you've got basic subjects, and finally you've got emerging, okay? So if you focus on this, we can see that the words innovation, or the themes, innovation, performance, and knowledge are emerging or declining, okay? So these might be words that have recently just came up in some of the papers and not before that, maybe in the last few years. Yeah, like now, if you scroll over it, you can see the full list of these emerging or declining themes. Innovation, performance, knowledge, technology, networks, research and development, etc. Industry. The most established themes would be your basic themes and your motor themes, okay? So here we've got the word management, entrepreneurship. Here we've got citation analysis, bibliometric study. A lot of these words are kind of similar with each other. It's not the first time that I've seen technology or anything related to technology, AI for example, come up in emerging or declining, probably emerging in this case. And this is a very, very quick way to review a lot of papers at once that you can get from a repository such as PubMed or Scopus in order to come up with a question. So that's the kind of stuff that I recommend to students, all the stuff we talked about today. I hope that this helped to with your own thinking about where to go with a research study. Next time I'm definitely going to do maps, and I wanted to do that already, but I didn't get the time. There's some great map making libraries called like Terra, and you can use other ones as well that are more basic. I'm not sure how much time we'll spend on that. Maybe I could just get into some basic maps unless there's a reason for me to go too deep with rasters and other species distribution modeling. But for now, I hope you have a good day and good luck with your projects. Bye.